All right, so on this video, what we're going to be doing is solving exponential equations using logs. Now, before I jump into any examples, we have to understand this property. And the property is when I have a number b, a base b, any number, raised to the power of x equal to number y. Again, if I have b raised to the power of x equals to y, I can rewrite this. Rewrite it as a log, which would be the x comes down, the b is going to move to the other side, but we have a log of base b of y. So again, if we have b raised to the power of x is equal to y, we can rewrite it as x equals log base b of y. Right? And if you need to pause this so that you can write down this property, make sure you do it. And with that said, let me jump to the first example. All right, for this example, what we have is a base of 6 raised to some power x equal 1,000, let me make sure I'm doing it right, equals 1,296. So again, before I even solve for that x, we have to understand what we're looking for. So we're looking for a value of x such that when we raise 6 to that value, we get 1,296. So again, 6 to what power x, what number x, will give me 1,296. Now, do not confuse this with simply having 6x, 6 times x is equal to 1,296. If we had this, we do the opposite of multiplication, we divide on both sides, and we would be done, whatever this is. But again, we don't have 6 times, we have 6 raised to the power of x. So what we have to do is rewrite it as a log. So what we have now is x equals to the log base 6 of 1,296. So again, we can think about the way we got rid of this 6 or the way we move this 6 to the other side is by doing the opposite operation of the base, which is using the log. All right? So now we're done. For this part, we have to absolutely use a calculator and evaluate. Again, when I put it in the calculator, when I put when I put log base 6 of 1,296, what I get is x is equal to 4. This is my answer. So basically, if I have 6 raised to the power of 4, this is equal to the 1,296. And again, this is what we were looking for. All right, so if I'm going or I'm erasing too fast, again, make sure you pause and write down the steps. All right, for the last problem that I'm gonna work with you guys, number 3. For this one, let's say I have base 9, was not the last one, it's the second one. Base 9 raised to the x plus 10 plus 3 is equal to 81. All right, so again, what I'm doing is I'm solving for x, so I want to get x by itself. Therefore, I have to get rid of this positive 3. Then I have to get rid of that 9. And then I can get rid of that positive 10 in that order. And we're not really getting rid of those numbers. We're just moving those numbers to the other side of the equation so that we can get what x is equal to. All right, so by now, you know the opposite of positive 3 we know is minus 3 on both sides. So on the right side of the equal sign, what I end up with is 9 raised to the x plus 10, positive 3 minus 3, that cancels, equals to 81 minus 3 we know is 78. Now, how do I get rid of this 9, or how do I move this 9 to the other side of the equal sign? Well, again, what we have to do is simply rewrite it using logs. So what I end up with is x plus 10 is equal to log of base 9 of 78. Again, this part we have to put it in our calculator and evaluate. So what I end up with is the x plus 10 equal to, and log of 9 of 78, this is about 1.982. I'm just going to use 3 numbers after the decimal. Now, the last thing we're going to do, since we want x by itself, is we have to get rid of this positive 10 by doing the opposite of plus 10, which is minus 10 on both sides, minus 10. Bring down the x, positive and negative 10, that goes away. I don't have to rewrite it or put 0. Equals 1.982, positive 1.982 minus 10, and we have more negatives. This gives me negative 8.18. Oh, sorry. Nope. This gives me negative 8.018. So that is the value of x. And again, what we wanted to do from the beginning is get x by itself. So I had to get rid of that negative 3 first. So I did. Then I had to get rid of that positive 9, the base 9, by doing the opposite operation of an exponent, which is rewriting it basically as a log. Then we evaluate this part here and we get about 1.982. I got rid of that positive 10 by doing the opposite, and I got x is equal to negative 8.018. All right, now for the last problem. It's almost 12 at night, so that's why I'm losing my mind. All right, for the last one, what we have is, we have 2, this one's going to be a little bit different, times base e, times base e, raised to the power of x minus 1 minus 10 is equal to positive 10. Again, keep in mind, what we want to do is get x by itself. We want to solve for x. So we want to get rid of everything here around x, move it to the other side so that we can get x by itself. So that's what we're going to do. And we're going to follow this order. First, we have to get rid of the negative 10. Then we get rid of the 2. Then we can get rid of the base e. Then the negative 1. In that order. So to get rid of the negative 10, I have to do plus 10 on both sides. Keep in mind, whatever you do to one side, do it to the other. So I end up with my 2 times base e raised to the power of x minus 1. Negative 10 plus positive 10, that goes away. 0, I don't have to write it down. Make sure you bring down your equal sign. Positive 10 plus 10 is equal to 20. We're getting closer. Now what I want to get rid of is the 2. And before I get rid of the e, I have to get rid of the 2. So the opposite of, keep in mind, multiplication is division. So I divide by 2. Divide by 2 on the other side as well. What I have is e raised to the power of x minus 1 equal to positive 20 divided by positive 2 is positive 10. Now I can get rid of the base e by rewriting it as a log. So I'm going to have x minus 1 is equal to log base e of 10. This part, again, we have to evaluate in the calculator. And when I evaluate log base e of 10, what we get is, so again, I'm going to have my x minus 1. What we get is about 2.302. And again, I'm just keeping it to 3 numbers after the decimal. And again, the last step to get rid of this negative 1, I'm going to do the opposite of minus, which is positive 1 on both sides. So I have x, negative 1 and positive 1, that goes away, is equal to, keep in mind, positive 2.302 plus 1 is equal to 3.302. And we're done. So our answer is x equals 3.02. Bam.